All right, guys. So today we're going to be talking about something called isotopes. But before we do that, let's just kind of review what we talked about last class. I know it's been a long weekend, so just want to refresh your memories. So you'll need your periodic table pretty extensively today. You'll also need a calculator. I'm cool with you guys using your phone calculator or calculator on the Chromebook, so that's totally fine. Okay, but let's start by answering number 1 and number 2. Okay, I'll give you guys 2 minutes to try that out with the person next to you. So on your paper, I just want you guys to try number 1 and 2. Which element has 16 protons, and how many protons does uranium have? Today? All right, so which element has 16 protons? Pretty easy. Protons are the number on top of the box. So we just look for the element that has 16 on top of the box, and that's going to be S for sulfur. So for number 1 on your notes, just make sure you guys put number 1 is going to be S for sulfur. Okay, if you wrote the full name, that's fine. But again, you can always just write the element. All right, number 2, how many protons does uranium have? So we're going to take a look at the periodic table to find uranium. Uranium is at the bottom right here, and the number on top of the box, God bless you, is 92. So we're going to put 92 for protons. So we got sulfur, which has 16 protons, and uranium has 92. Alrighty, any questions on those? Hopefully it's not too bad. Again, it's just a review from last time. All right, so last time we met, we talked pretty much exclusively about protons, right? You guys don't need to write this down, okay? But we talked about how there's different things that make up the atom, right? So the first one we talked about last class is protons. Today, we're going to be focusing on the second one, which is neutrons, okay? So you guys don't need to write this down. I'm going to just show you guys one quick graphic so you guys don't need to copy it down, but I'm going to explain it, okay? All right, so actually, you do need to write this down. So today we're going to talk about isotopes. Sorry about that. And I do want you to write the 2 definitions for isotopes. So isotopes are different forms of the same element, okay? So we talked about how there's different elements which are the different types of atoms. Today we're going to talk about the different forms of the same element. So for example, with hydrogen, there's hydrogen, which always has 1 proton, but there's multiple types of hydrogen. It's just like how there's multiple types of oxygen and uranium, which we'll talk about right now. They're different forms of the same element. And the key thing is this definition right here. Okay, isotopes, they always have the same protons, but they have different number of neutrons, okay? So they have the same number of protons, but they have a different number of neutrons. Just make sure you guys write both those definitions down. It'll help clarify some things for you. And this one right here will actually help you answer a lot of the questions on your assignment today, okay? So isotopes, different forms of the same element, same protons, but they have different neutrons. And that changes what the atom does. Important. Okay, so the reason why isotopes are important is because depending on which isotope you have, you can have the same element, but they do completely different things. So the example we'll be looking at is uranium. So if you look here, we have 2 isotopes of uranium. The first is uranium-238, and it's very stable. We use it to make the frames for yachts, so it's on boats. Okay, if you pick up a rock outside or pick up some soil, there's going to be a little bit of uranium-238 in there. Nothing dangerous. It's just an element inside of rocks and soil and water. Okay, now the other isotope, however, is uranium-235, and this is radioactive. This is what we use for nuclear fuel. So if you guys watched Oppenheimer about how they made the first atomic bomb, this is what they were trying to enrich. They were trying to get a bunch of uranium-235, and again, it's used for nuclear fuel. It's radioactive. It will kill you if there's a good amount. If there's a small amount, it'll probably just give you radiation poisoning, maybe some cancer later, but not very safe, right? So it's crazy because they're both uranium. They're the same element, but they're completely different because of the neutrons. If you guys look right here, they both have 92 protons, but the difference are going to be the neutrons. So 146 for this one, the stable one, and 143 for the radioactive one. Okay, so that's what isotopes can do. Depending on the neutrons, it completely changes what they do. Now, if you're interested in how the atomic bomb was made, basically, what they did was they got a uranium-235 atom. You guys don't need to copy this down. Okay, this is uranium-235, and what they did is they shot a neutron into it. Okay, that broke this atom apart. Basically, the atom explodes, and it breaks up into these things right here. It shoots out other neutrons, and then there's another uranium-235 right here, which gets hit by this neutron, and this one blows up, and then it shoots out more neutrons. And then if you guys watch the movie, they talk about a chain reaction, sustained chain reaction. That's pretty much what it is. They shoot a neutron, one uranium-235 pretty much blows up, which makes another one blow up, and another one, and another one, another one, and that releases a lot of energy, and that's how we got the atomic weapons and how we get nuclear fuel. Okay, so that's why isotopes are important. That's why how they're used in industry these days. But we're not going to talk about any complex stuff. We're just going to talk about the basics. Okay. All right. So the important thing for isotopes is this right here, and this is the formula we'll be using. So copy this down. We're going to be talking about something called mass number today. And mass number is very easy. If you can add two numbers together, you'll be pretty much good for today. Okay, the mass number is protons plus neutrons. Okay, the mass number is protons plus neutrons. All right, so let's talk about how we can use the mass number to identify different isotopes. So we'll jump right into a practice problem. So there's two different ways we can communicate the identity of an isotope. The first one is a name, which is pretty simple. You just write the name of the element, so magnesium, and then you put a dash, and then this number right here in the back, this is the mass number. So on your paper, I want you to write number 3, and I want you to write the name, magnesium-26. Okay, just know that this number back here is the mass number. This number is protons plus neutrons. Okay. Okay, so we can write an isotope's name by writing the element's name. So here our example is magnesium. That's an element on the periodic table. We put a dash, and then we put the mass number behind it. And that number behind it is protons plus neutrons. All right, so another way we can communicate the identity of an isotope is through the symbol. So symbol is very easy as well. All we got to do is go on the periodic table and look for the elements. Okay, so we're going to go to the periodic table and look for magnesium. So if we look for magnesium, it's all the way on the left, and magnesium is Mg. So we're going to write Mg for the symbol. So this is the next part of the problem. We're going to write the symbol, which is Mg. Yeah, what's up? Yeah, that's correct. So Mg is the symbol for the element, but we're talking about an isotope now, so we have to include this number right here, the 26, the mass number. That's very simple. You just put it on the top left. Okay, so top left, 26, Mg. And this is the same thing as magnesium-26. And again, this number on the top left is going to be the mass number. Okay, make sure you put it on the top left because top right is for something else. We'll talk about that in future classes, but just make sure it goes on the top left. And again, this number is protons plus the neutrons. Okay, so we're going to fill out the rest of the table. We got to figure out protons and neutrons. Well, protons is really easy. This number comes from the periodic table. So if you guys look at the periodic table for protons, for magnesium, it's just a number on the top. It's what we did in our warm-up. Magnesium has a 12 on the top. So that means magnesium has 12 protons. Okay, so that's how you can find protons, just on the periodic table. All right, and then the last part, neutrons. If you guys notice, this number 26 is protons plus neutrons, right? So if we want to find neutrons, it's very simple. You just get the mass number, and then you subtract the protons, and that'll give you your neutrons, which is 14. So magnesium 26 has 12 protons and 14 neutrons. Okay, and that's how you can identify the name, the symbol, how many protons and how many neutrons an isotope has. Okay, it's pretty much, this is the formula right here that'll help you with everything. Just remember this number at the end is protons plus neutrons. Okay, any questions about that one? All right, so for number 4, we have the symbol, and so we got to kind of find the name. So we're going to look for Ne on the periodic table. So if we go to the periodic table and go all the way to the right, we have Ne, which is neon. Okay, and while we're at it, let's take the 10 protons as well to answer the other question. So this is going to be neon. So neon has 10 protons, which we got from the periodic table. And if we write the name, it's neon. We're going to put a dash, and then we put the mass number, which is 19 behind it. So the name is neon-19. Okay. All right, and then to find the neutrons, very simple. We take the mass number, which is 19. We subtract the protons, so 19 minus 10, which will give you 9. And that's going to be your neutron. So the vast majority of your assignment problems will be like that. So if that was pretty easy for you, assignment today should be pretty simple. Okay. Any questions on number 3 or 4? All right. All right, so number 5 is going to be very similar to this. The only difference is we're going to add a picture of the element. Now, I promise you, I'm not going to have you draw 26 or 19 protons and neutrons. We'll keep the number small, but the concept will be pretty similar, okay? So let's go to number 5. So number 5, we're going to draw a picture of lithium-5, and we're going to label the protons, the neutrons, and the electrons. So similar to what we did last class, we want to figure out how many protons, how many neutrons, and how many electrons this atom is going to have. So we're going to figure all 3 of these out, and then we can put them together in our drawing. Okay, so here we're looking at lithium-5. All right, so let's start with the protons. Protons, very easy. We just look for lithium on the periodic table and the number on top of the box. So if we look at lithium, lithium is right here, and it has a number 3 on the top. So lithium has 3 protons. Okay, so for protons, let's do 3. God bless you. So 3 protons. All right, now if you guys remember from last class, we said the protons and the electrons are going to be the same number. Okay, I think today's the last day we're going to be doing this, so I guess you guys can enjoy this free answer. Okay, 3 protons and the same number of electrons. Okay, and that's because protons and electrons were always the same for neutral atoms. All right, and then last but not least, we have to find the neutrons. Okay, we don't have any info about it from the periodic table, so we have to use this number right here, the mass number. So we have 5 as our mass number, and if you remember, 5 is protons plus neutrons. So if we want to find neutrons, all we have to do is we just need to do 5 minus 3, right, the protons, and that's going to give us 2 neutrons. Okay, easy way to check your answer is just add these up, add the protons and neutrons, and they should add up to your mass number, which is 5. Okay. All right, any questions on how we got protons, neutrons, electrons? That part should be pretty simple. All right, now we can do the picture, which is the exact same thing that we did last class. We're just going to put them together in the atom's structure. So protons and neutrons go in the middle, and they're touching each other. So we're going to have 3 protons that are all connected, and 2 neutrons, which are stuck together to the protons and each other. Okay? So this is your nucleus. All right, and then lastly, we're going to draw our 3 electrons. And remember, electrons fly around the nucleus, and they're not touching anything. They're not even touching each other. So they're all separated. You can orient them however you want. As long as they're separated from each other and from the nucleus, you're good to go. All right. And there you go. That's your answer to number 5. That's how you can draw the structure of this isotope right here.